Alrighty, today we're going to be having a look at triangulation. And often with triangulation, it's going to be using the sine rule, but on top of that, it's also going to be using some of our angle tricks that we learnt from bearing. So Trent is standing on one side of a river. There's a river running along here, and has measured the distance from two poles, A and B, on the river's edge that are 100 meters apart. That's the 100 meters there. He measures the bearing at A and B to pole C to be 30 degrees true and 340 degrees true as shown. So you can see on the picture where the angles have been put. So the first question is just calculate the distance from the pole A to pole C on the river. So we want to find this length right here. Let's call it X. So looking for that length over there. Alrighty. So let's start off by just working out some of these angles inside the triangle. We have this beautiful triangle here, but we don't know any of the angles inside it. So first of all, let's work out this angle. Well, this angle A, well, since that whole thing is a 90 degrees, you can see that this whole thing should be a 90 degrees, that if we go 90 degrees minus 30, it's going to be 60 degrees. So this angle in here is 60 degrees. Using a similar logic but slightly different, from this north line all the way to this line would be 270 degrees. So to find angle B, we can just go 270 minus, other way around, 340 degrees, since that's bigger than 270, minus 270 degrees. And that's going to be equal to 70 degrees, which is this internal angle here. So we don't want any of these like reflex angles or obtuse angles. We just want these smaller angles that are actually inside the triangle. Okay, so now that we've got these two, we can actually also work out angle C. So let's do that. Angle C is going to be equal to 180 minus 60 minus 70, which is 50 degrees. There we go. And we can double check that all of this makes sense, because if you add 50 plus 60 plus 70, you get 180. Alrighty, let's redraw the triangle without all of the true bearings and stuff, and just then see whether we can work out what X is. Alrighty, so since we want to find X, well, that means we need to use this pair here, which, if we remember, this is going to be B, this is side A, and this is going to be side C, using our naming conventions. So we're definitely going to want B over sine B. And then we need a pair of information. You can see A and A. Well, I've got the angle A, but I don't have the side A, so I can't use A. So I have to use C, since I do have both the angle and the side. So B over B is going to equal C over sine C. Substitute everything in that I know. X over sine 70 is equal to 100 over sine 50. Rearrange to find X, so that means times both sides by sine 70. And we can now work out X by just evaluating what's on the right-hand side. We get 122.66815 ... and it says round to 2 decimal places, so round the 6 up to a 7, because the next digit is an 8. Alrighty, and the answer's in meters. Alrighty, so there's actually our answer to part A. Let's have a look at part B. Part B asks us to calculate the width of the river to the nearest meter. Well, the width of the river would be like drawing a vertical line down from C, and then that would form us a right angle triangle. So rather than trying to sketch this out, let's just draw that new triangle, especially since we now know what X is. So we'll use the left-hand side of it, and then we'll redraw it and see if we can see anything. So here's the triangle. We've got the right angle here. We're looking for the width. Let's call it W for width. We just worked out that, actually we know this angle, because that's the same angle we've already worked out, which is 60 degrees. We don't know this length. We, in fact, don't know this angle, but we could work it out if we wanted to. We do know this length, this is X, so this is 122.67 meters. And that's actually enough information, because we've got the right angle. because this could be my opposite, this could be my hypotenuse, this would be my adjacent. So I can use sine theta equals opposite over hypotenuse. So I'm not even now using the sine rule. I'm just using trigonometry because I've got a right angle. So if you've got a right angle, you are allowed to use trigonometry if you prefer. So we get sine of 60 equals the opposite w over the hypotenuse 122.67 times both sides by 122.67. And we get our width will be equal to 122.67 times sine of 60, which is equal to 106.235 ... And if you read up, it says to the nearest meter, so I can round that down to 106 meters. And there's my final answer. That's how wide the river is. Alrighty, so there we go, just a little bit on triangulation using a bit of sine rule and as well just a bit of trigonometry. See you in the next one.